Hello, my name is Ardi and we are going to solve problem E3.16 from IRWIN's book. So the question is find V0 in the network in figure E3.16. So V0 is this one here, and we need to use loop analysis, right? Because this section is about loop analysis. Okay, let's see what we can get from here. Let's draw our loops here. Let's draw this as loop I1. And then the direction I just follow this the arrow of the current source. So we'll have I1 here, and for I2 I will do it like this because I just want to follow the arrow of the current. So I will have I2 here. Then for I3 I will just do clockwise. We'll have I3 here. Good. So now we have three loops, I1, I2, and I3. But then right off the bat, we know that I1 here is the same as this current source here, right? Because that is the only current that passed through this branch here. So we will have I1 is the same as 4 milliampere. So let's save that. So we know that I1 here in our circuit is 4 milliampere. Good. And the second one, we also know that this I2 here is the same as this current source here. So this I2 is the same as this current here because that is the only current that passed through this branch here. So we will have I2 is equal to 2 milliampere. Okay. And now we still need to calculate I3, right? So let's do KVL at I3. KVL at I3. KVL said that the sum of the voltage in a loop will equal to 0. And here I3 is flowing from the negative terminal to positive terminal, so we will have negative sign. So we'll have minus, and the magnitude will be 4. And then plus, we will have 1 kilo ohm resistor here. So I will have 1 here multiplied by, we will have I3 here. And we subtract I1 from it because I1 is flowing to the opposite direction on that component. So we'll have minus I1 here. And then we still have one more component, which is this 4 kilo ohm resistor. So we'll have plus 4, and the only current that passed through it is I3. Good. All of that will equal to 0. Okay, now let's do some simplification here. So we'll have minus 4. I multiplied by this term, so we will have this term I3 minus I1. And then plus 4I3. And that will equal to 0. Good. Now let's do another simplification. So we can rewrite this as minus I1 and then plus 5I3 because 1 plus 4 is 5. And let's move this minus 4 to the right hand side. So we will have 4 here. Good. But then we know that I1 is 4 milliampere. So let's just plug that into our equation here. So we will have minus 4 and then plus 5I3, and that will equal to 4, right? And so we'll have 5I3 is equal to 8, or I3 is equal to 8 divided by 5. What is 8 divided by 5? I think that will be 1.6, right? So we'll have 1.6 milliampere. Good. But the question does not ask about I3, but it is asking about V0 here. But then V0 can be calculated using Ohm's law, right? V0 is just I3 because that is the only current that passed through this resistor, and then multiplied by 4 kilo ohm. Okay, what is I3? We'll have 1.6 milliampere then multiplied by 4 kilo ohm. Okay, milli and kilo will cancel each other, so we will have volt as the unit. 1.6 and 4, that becomes 6.4. The unit here will be in volt, so that is V0. Is it the same as the answer? It looks slightly different, but actually it's the same because 32 multiplied by 2 is 64 and 5 multiplied by 2 is 10 volt. So we can rewrite this as 6.4 volt, which is the same answer from our calculation and the answer given by the book. So hopefully this will help you to solve this particular problem here. Thank you for watching and see you in the next video. Bye bye.
Tapi kan langsung keputusan tentang apa sih terserah.